Hello friends, welcome to my channel. In this video I will cover most important parts of thermodynamics for Isro 2017 exams. In thermodynamics, one or two questions they are asking from graphs based on graph. So first I will tell some graphs, after that some theory question and formulas I will tell. This is part 1. In thermodynamics, 7 to 15 questions every year they are asking. In thermodynamics part covers also power plant. And from thermodynamics and power plant 7 to 15 questions you will get. Here maximum questions are based on concepts and formulas. So within 1 minute you can answer the questions. Per question maximum you can spend 1 minute. So it's very easy to score mark in this section. No much more calculation, so you can save your time also. So first I will tell about the PT diagram of pure substance. PT and TP diagram also, sometimes they are asking TP diagram for Joule-Thomson coefficient, that is also important. Later I will tell you. Here pressure, here temperature. In x-axis temperature, y-axis pressure. This is sublimation curve, blue color. Sublimation curve. Here black color, this is vaporization curve. This one green color. This is fusion curve. Here critical point. It's triple point. This green color is fusion curve of water and this yellow color is fusion curve of other than water. So for water it's negative slope. For other than water, other substance, it's having positive slope. Sublimation curve also always positive and vaporization curve also always positive. This one also very important. So you remember, this is always positive, sublimation curve, vaporization curve also always positive. Here fusion curve for water it's negative, other than water it's positive. Then critical point, here this side it's solid, here liquid, this side vapor, here also vapor. In sublimation curve, if one substance is here, in this condition 1, if you give heat or if you increase its temperature, directly it will convert to vapor. From here solid, here it will convert to vapor. And at critical point latent heat is 0. And here triple point, all three phases are possible. One more thing is important here, in PV diagram, triple point will come as line and in PT diagram, triple point will come as point. Here it came as point. But in PV diagram, it will come as a line. At critical point, latent heat is 0 and at critical point, critical pressure is 221.2 bar, and critical temperature is 374.15 degrees Celsius, and for triple point pressure is 4.587 mm of Hg mercury. Triple point temperature, this one once they asked in Isro examination, triple point temperature. In the RRB examination also they asked this question, triple point temperature. Next is PV diagram of pure substances other than water whose volume increases on melting. So here this is P versus V volume. Here this side it's solid, here S plus B, solid plus vapor, here solid plus liquid. This is saturated solid line, this line, saturated solid line. This is saturated vapor line, this one. Here these two lines are saturated liquid lines. Here this side solid, solid plus liquid. Here liquid, liquid plus vapor, this side only vapor. Here solid plus vapor. Here critical point, liquid directly converts to vapor, latent heat is 0. So here most important is this line, triple point line, this one. This is came as line in PV diagram. So many times they asked in IAS examination. But in case of PT diagram, it will come as point. This is PV diagram for water whose volume decreases on melting. Here this is saturated solid line, then solid plus liquid. This is saturated liquid line. Here critical point, this point is critical point, then saturated vapor line, then our triple point line, this one. So this side solid, solid plus liquid, then this side liquid, liquid plus vapor, vapor, solid plus vapor. Then next is quality or dryness fraction of steam. X indicates the mass fraction of vapor in a liquid vapor mixture. If you take 1 kg of liquid vapor mixture, then x kg mass of vapor and 1 minus x kg mass of liquid. From here we will calculate x percentage. X is equal to mass of vapor divided by mass of vapor plus mass of liquid. So many times they will ask this type of question, you have to calculate. They will give mass of vapor and mass of liquid, then you have to calculate the dryness fraction. This is important for IAS also. MV is mass of vapor and ml is mass of liquid. M is mass of vapor and ml is mass of liquid. Dryness fraction varies from 0 to 1. For dry saturated, x equal to 1, and for saturated liquid, x is equal to 0. Then HS diagram or molar diagram for pure substances. For water, this is H and S. In x-axis entropy and y-axis enthalpy. Enthalpy versus entropy diagram. This is from here to saturated liquid line, then saturated vapor line. In this side liquid, here liquid plus vapor, this side only vapor. This is critical point. Here constant pressure lines. Pressure constant. Here in this liquid and vapor region, pressure and temperature lines both are identical, and in vapor region, after crossing the saturated vapor line, this is constant pressure line, positive slope, and this is constant temperature line, green color. It's having negative slope after the saturated vapor line. This is also important. Here liquid and vapor region both are identical. This is the end of part 1. Thank you friends. Thank you for watching my video. Thank you.